Again, here are your derivatives of sine and cosine. You will have to memorize them. They will be on a flashcard that you will make next class. In addition, with these other 4 right here, okay, these are also derivatives that you are going to have to memorize because honestly, tangent of x, secant squared of x, secant squared, or secant of x is secant of x times tangent of x. These are things that you can actually figure out, and there are proofs for all of them. However, we don't have enough time to do all of those things, okay? This is not a proof-based class. We just need to know what they are, okay? If you would like to learn about them, there are little kind of QR codes here, though, that you can scan along and look at the proofs of some of them, okay? We're going to do tangent of x together. That one's actually not too bad, so I do want to show you that, but that's when we get to the quotient rule. I will show you that, okay? So all 4 of these we are also going to add to our note cards so that you guys have those so that you can memorize them, okay? All right, product rule. This fancy little notation here, it's really not that bad though, okay? Before we do this using the product rule, we can actually find the derivative of this thing, right? But what do I have to do first? Distribute, right? So let's go ahead and distribute this out for h of x and find the derivative, okay? We are then also going to do it with the product rule, okay? I'm just going to show you that you can do it with both things. In some cases, doing it the way that we've done the last class might be easier, but you will have to use the product rule on some things, okay? Try it out. So this is our derivative right here. We're now also going to use the product rule, which is new for you guys. The notation is up above. And we're going to show you that you can get the same answer using either one, okay? So the product rule was invented by I don't know who, but someone, to make our lives a little bit easier when we have 2 functions multiplied together, okay? So it's not like just 4 times the quantity x plus 2. That's not 2 functions, right? 2 functions means 2 things that have a variable in it, okay? So I've got this first function. We're going to call this f of x, okay, for our notation here. We've got f of x, and we have g of x, okay? This notation up here, d dx, that is the derivative with respect to x, okay, of 2 functions multiplied together. So that's what we've got there, our 2 functions multiplied together. So I've got my red, and I've got my blue. Okay, the first thing that we are going to do is we are going to take the derivative of the first function. So what is the derivative of 3x minus 2x squared? 3 minus 4x, right? That is the derivative of that first function. Yes? Okay, then we're going to multiply that with the second function, not the derivative. There's not that little notation of f prime or g prime. I'm just multiplying that with 5 plus 4x. Okay, so I've done the first part of my product rule. Now the second part says I'm going to take f of x, which is just that first function. Oh, and I'm adding, right? So I'm adding this first function, which is 3x minus 2x squared, and then I am taking the derivative of the second function, okay? Derivative of 5 plus 4x would just be 4, right? Okay, now, if I were to actually distribute these things, okay, and simplify and combine all of my like terms, you will get the same answer that we did by first distributing and then finding the derivative of that, okay? That work I showed up here kind of on the board. So you see, after I've distributed everything, I can combine my like terms and I get the same answer, okay? Now, in this example, which one do you think was easier? The first one was probably easier, right? Less mistakes to make, less negatives to do, right? So I would agree that the first one was probably easier. However, we're not always going to have 2 functions like this when we are doing the product rule. We might have like sine of x or sine of x plus 4 or something like that, right? We are not going to have just a polynomial. So in that case, we will have to use the product rule, okay? Does that make sense? Okay, just like a lot of things in math, there's more than one way to necessarily do them, okay? So if I look at these two examples, I hate that this is just in the way there, but it should be on the second page. We've got two examples, 3x cubed and sine x. Those are being multiplied together. So I'm going to color code these here as 3x cubed and sine of x in blue. This is one of those examples that I cannot use the product rule, or not the product rule, the power rule to solve this, right? Because I have two things multiplied together. So I can't just distribute and take the derivative of each term, right? So we have to use the product rule, okay? The product rule says I am taking, the derivative of the first thing. Oh, one other thing that I forgot to say. Could I switch the order of these two things? Yeah, it doesn't necessarily matter, right? We're just adding them together. So the order doesn't matter if you flip-flopped them or if you flip-flopped like the derivatives, right? That's not going to matter as long as you have all of them there, okay? So derivative of 3x cubed. What's that? 9x squared, okay? Times my g of x function. So just times sine of x. And then I'm going to add my f of x function, which is 3x cubed, times the derivative of sine of x. The derivative of sine of x is cosine of x. Okay? And that is it. That is all we are doing. Okay? When we are doing quotient rule, product rule, any of that kind of stuff, it just asks you to find the derivative of things. Please, for my own sanity, do not simplify anything. It's probably the first time you'll ever hear a math teacher tell you that. Because if we all start simplifying these things and simplifying them differently, and we're going to have maybe minuses in the wrong spot, things are going to be a little weird. It's going to take me forever to grade these things, okay? So whatever you get when you find the product rule by using this definition, that's it. Don't do anything else, okay? Sound good? Okay. Why don't you guys try out letter B for me? Cosine of x and 9x, those are being multiplied together. Find the derivative. All right, did we get what I have up there? 9 times cosine x, 9x times negative sine of x. Could we have also changed this to a minus 9x times sine of x? Things like that would be fine. But if you start doing crazy things like trying to take out 9s and stuff, don't do that, okay? Just do the product rule or the quotient rule, okay? All right, quotient rule is next. Here we go. Okay, over there is a proof. You can click that QR code and do that proof if you would like to see it. However, we are not going to do this because look at this formula right here. Do you want to derive that by a proof? I for sure don't, okay? So there is, I don't actually know what this song is, but I do know that the phrase low D high minus high D low all over low squared is what we are going to use in order to remember the quotient rule, okay? What do all of those things mean? Let's go ahead and zoom in here and write some stuff down, okay? I'm going to color code some things again. I'm going to have my numerator here be red and my denominator is blue, okay? Now, when it says low, it means the denominator, okay? So this phrase of low is our denominator, or our g of x in the bottom there, okay? D high, if I look up here, this thing, I'm taking the derivative of the numerator. So the derivative of the higher term, right? The numerator. Derivative of the numerator. Okay, and then I want us to cross this second low D high out because there's only one low D high. Then it says minus. Minus here. High D low. So high is our numerator, or our f of x function. And then D low stands for the derivative of the denominator. And then we need to cross out this second high D low. There's only one high D low. And then it says all over, which means division. So that whole thing on top is being divided by low, low, or low squared. So that is my denominator squared. Okay, this is going to take practice. I don't expect us to memorize this formula. I expect us to be able to remember low D high minus high D low over low squared. Okay, so that's going to be, again, another thing that's going to be on one of your note cards that you'll write down. I'll have you probably write this fun definition down, but I'll also have you write the low D high minus high D low part. Okay? So again, this, when you're using the quotient rule, you definitely, what did I do? Did I do something?
Is this a real song or is this like a rap song?
I don't know what song this goes to, actually, to be quite honest. I didn't write that there, so I'm not sure. It's probably a song. It probably goes to some sort of tune.
So it's like,
Let's look at this in play here. How does this work? Okay? I'm going to start with example B, and I'm going to have you guys try out example A here in a minute. Okay? So I'm going to color code my stuff. My numerator, I chose red. My denominator, I chose blue. So my derivative of this function is low, which is x cubed. D high, which is the derivative of sine of x, which is cosine of x, minus high, which is my numerator, d low, which is the derivative of the denominator. What's the derivative of x cubed? 3x squared. And that whole thing is being divided by x cubed squared, or low squared. Okay? Now, yes, technically, could I simplify that to x to the sixth? Yes, and technically, could I factor out an x cubed or an x squared from everything? Yes, don't do that, okay? Just do the quotient rule. Less work for you, less headache for me to grade, okay? Good stuff. Any questions on how I got those values? Okay, it's just going to take some practice. So I want you guys to try out letter A for me, which is over here for some reason. Okay, letter A is over there. Try that out doing low D high minus high D low all over low squared. Then I'll make sure we all have the same answer. Okay? All right, did we all get this for our derivative? Yes? Question about, I heard someone say, do I need parentheses? For something like this, you don't necessarily need a parentheses there for 5, but we do need parentheses around like the x squared minus 1, right? Because it's taking like the entire quantity and squaring it, okay? And again, please, for my own sanity, do not simplify any of this, okay? Leave it like this, okay? All right, so that is your quotient rule, okay? You'll get more practice with that over the homework. If you look here, we are going to find the derivative of tangent together using the quotient rule, okay? The function is tangent of x, which we could also rewrite as what? Sine over cosine. We didn't forget everything from pre-calc. Okay? Which is now something that we can do to find the derivative of this is use the quotient rule, right? Yep, so low D high, I'm going to again color code. So low D high, the derivative of the top. What's the derivative of sine? Cosine of x. Minus high, which is sine of x, times the derivative of the denominator, which is negative sine of x. And that is all divided by cosine of x squared. Okay, let's rewrite this. Because cosine of x times cosine of x is what? Cosine squared of x. Same thing, sine of x gives me sine squared of x. And that's all divided by cosine of x, or cosine squared of x, right? Oh, sorry, this is positive. Yes, plus sine x. Otherwise, this wouldn't work. Because hopefully that numerator looks familiar. If I have cosine squared plus sine squared, what is that? 1. So this is 1 over cosine squared of x, which is secant squared of x. Okay? So the derivative of tangent, I said don't simplify except for we're showing the tangent of x, what it equals, okay? This is like a little mini proof, okay? The tangent of x, derivative of that is secant squared of x, okay? That is, again, one of those that you need to have memorized, okay? This is where all those other 4 things came from at the top. There's like secant, and there's tangent, and there's cosecant. All those things on top you will have to have memorized, okay? You don't see them a lot, but they will come up, and we need to know them, okay? All right. Now we're going to look at my favorite derivative, e to the x. If I take the derivative of e to the x, what do I get? E to the x is the best one. It's the same thing both ways. Okay, so if I look at example A here, if I have 5e to the x, my derivative of this would just be 5e to the x. Okay, we again do not need to use product rule because 5 is just a constant, right? So anytime we have a constant, we take the derivative of the function and then multiply it with that constant. Okay, letter B. What am I going to get? E to the x minus 4. And the last one, 7e to the x. And derivative of cosine is negative sine, which negative sine, or plus is fine there. Okay. All right, now let's look at a natural log of x. If I have the natural log of something, okay, this is your rule. We take the base to the same power, so just like we did for e to the x, right? It's e to the x, right? But then it says times the natural log of a. Well, if we thought about this with e to the x, right? This would be the same thing if I was taking the derivative of this. That's e to the x times the natural log of e, right? Which, that's 1, right? So that's why there's kind of 2 rules for this. If it's the base of e, it's just that e to the x. But if it's a different base, obviously the natural log of like 5 is not going to just go away, right? That's a number. So this first one here, I'm going to change this to just be 5 to the x. If this was just 5 to the x, your derivative of this function would be 5 to the x times the natural log of 5. Okay, let's change this one to be 2 to the x. 2 to the x minus 4x. Take the derivative of this. 2 to the x times the natural log of 2 minus 4. Okay. And let's change this one to just be 7 to the x. And write your derivative and check with your neighbor. All right. Did we get this? Or you could have had a plus here. That's fine too. Okay. Good stuff. So that is a natural log one if you have a to some power or a number to a power. Okay. All right. We've got 2 more. We've got the natural log and we've got the log. Trying to differentiate these. What do these give me? The derivative of a natural log is just 1 over whatever is there. Okay, 1 over x. So if I was looking at example 6 here, I've got a constant times the natural log of x. So this would just be 3 times 1 over x, right? I don't need to do the product rule because it's just a constant. And then what do I get if I take the derivative of negative 2e to the x? negative 2e to the x. And my derivative of negative 1/2 cosine of x, that's going to give me, derivative of cosine is negative sine, right? So I've got minus 1/2 times a negative sine of x. That would be fine to leave it like that. If you would rather put plus 1/2 sine of x, that's fine. Or if you want to do 3 divided by x, right? Just don't do anything too crazy with how you are simplifying your things, okay? Cool. All right. Now we've got derivative of a log, okay? Log base b of x. Our rule is we take 1 divided by the natural log of b times x. Natural log of b, that's just going to be a number, right? So it's whatever the natural log of your base number is, okay? So if I look at, oh, my example's on the next page. Here we go. Our last problem. Why don't we rewrite this so that my x is not in the denominator, yeah? So let's go as 5x to the negative 1 minus sine of x plus log base 3 of x. Okay, also be careful with your notations and things, right? If you are just rewriting this, make sure if this is supposed to be y, you're writing y. If it's supposed to be the derivative, make sure you're putting that y prime notation because they will take points off for that on the AP test. So when I find the derivative of this, what is the derivative of 5x to the negative 1?
5 over x squared.
Negative 5, yes. X to the negative second, or negative 5 over x squared, same thing. Derivative of sine is cosine, so minus cosine of x. And then this is the new one. If I have log base 3 of x, we rewrite this as 1 divided by the natural log of 3, and then times that with x. Okay, if you want to rewrite this a little bit so you don't have negative exponents, that is fine. You do not need to though, okay? This is the derivative of the function, which I need to put a notation here saying that it's the derivative, yes, okay? So make sure you are doing that as well, okay?